All right, and we are live. Welcome everyone to the next episode of Tech Excellence Meetup. The topic of today is property-based testing, avoid accidental quality by Mourjo Sen. Hey Mourjo, welcome.
Okay.
So let's get it on. So we are Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here you can find our team who organizes and manages these meetups. And of course, you can join us on the meetup.com where we always announce the new speaks, and you can follow us on YouTube, LinkedIn, X, Twitter, Discord, and GitHub as well. And big thanks to our sponsors, Optivem, Mocha IT, and Codartify, and to our partner QE Unit. So yeah, exactly. So property-based testing. Before I hand over to microphone to Mourjo, let me introduce him. So Mourjo Sen is a senior software engineer at Booking.com in Netherlands, but he's also an ex-Stripe, Koyak, Helpshift, and InReal developer. He is a software craftsman with over a decade of experience building resilient and scalable distributed systems. His passion lies in solving complex engineering challenges and driving architectural modernization. And throughout his career, he worked on diverse and impactful projects, including developing an identity verification platform at Stripe and leading the development of an edtech platform at Gojek. And beyond his professional work, he enjoys sharing his knowledge through technical talks, workshops, blog posts, and meetups, and that's why he's here. So again, Mourjo, welcome. So the topic of today is property-based testing. We are super excited, but before I hand over the microphone, I would like to remind the audience that if you have any questions about this topic or the question you would target Mourjo at the end of his talk, we will dedicate half an hour for Q&A. So after his talk, Mourjo will be happy to answer to all your questions. So do not hesitate to ask any questions, and you can do it in the YouTube chat section. So Mourjo, again, welcome. I handing you over the microphone, and I wish you good luck.
All right. Thanks a lot, and thank you for having me. Very honestly, this is, I would say, a career milestone to be speaking at this forum where so many people that I look up to have already spoken here. But thanks a lot for having me. So my topic for today is avoiding accidental quality with property-based testing. But before getting there, just hello and namaste. That's how you say hello in back home in India. I am originally from India. That's actually incidentally where I'm from right now, though I'm living in Amsterdam for 2.5 years, where my wife and I have moved, I think, at the beginning of 2023. And I think my wife is already on YouTube looking at this, so hi to her as well. Professionally, I've been a software engineer for 10 years. Right now, I'm working at Booking.com for 2 years now as a software engineer. And during the last 5 years, about like halfway through my career so far, I started writing and speaking about topics which I think are they have a foundational impact, right? They have a little bit more impact than other topics that I feel. So I'll write about those topics that I feel have a bit more like far-reaching consequences, so to speak. And I also speak about them like in a forum like this. And that is what brings me here today as well, to ask a very foundational question. I start with that because I really felt that during my career. So the question that I stumbled upon, let's say around like 2 or 3 years into my career, is that what are tests good for? What are tests in software good for? Because for a long time, I thought that the tests that we write were really good for finding bugs. And after a very public or visible bug, let's say that happened in production on my watch, and it went in and it was very public, and it wasn't a very nice situation to be in, although all the tests worked. I started realizing that maybe tests are not very good at finding bugs. What tests are really good for is rather verifying examples. Because traditionally, when we think of tests, what we do is we give the test some inputs and we expect some output. And we say that, okay, if the input and the output are what we expect, then the test passes, everything is green, everything is good. But falsely, I guess I was telling myself that this is also ensuring that there are no bugs in my code. but they are not the same thing. Finding bugs and verifying examples are quite different, because fundamentally verifying examples means that the author, that is me who's writing the test, has to know what you're testing for. Whereas the nature of finding bugs, on the other hand, has this innate unknown space that I may not be aware of, but my code might have a bug. So that's where I start today. What are tests good for? I thought that they were good at finding bugs, but really they're not. They're good at finding or verifying examples, the traditional tests that I'm thinking about. So let's start simple. Let's start with a simple method. This is a Java method. I hope I don't lose half the audience when I say Java, but anyway, when I have a simple method like this, it takes x and y, and it returns x plus y, that is addition. Now, if I had to write a test for this, I would write something like this. It's a very simple JUnit test, again in Java. The way what it does is it says that, okay, take 1.5, take 0, verify that the result is 1.5. Again, for the second example, take minus 100, take minus 1.8, add them together, you expect minus 1 or 1.8. Similarly, minus 1 and minus 100, when added together, is minus 101. And 130.5 plus 100, ensure that you expect 230.5. Now, this is, if this is the test that I'm writing for a production application or a method, I'd be happy, because the test, first of all, there is a test. That's already a good thing. And if it passes, I'd sleep soundly at night, thinking that, okay, everything is good. Everything is as I expected it. But the fundamental question here is that these 4 examples, are they enough to ensure that addition is working as I expected? Because I wanted to write a method that does addition, but what I did here is that I gave it like 4 pairs of numbers, and I said that the addition works for those. So example-based test, fundamentally what it does, it takes an input that I, as the author of the test, provided a priori beforehand, and I said that I expect a certain outcome, which is 2.5 here. And I said that, okay, every time you run this test, verify that 1.5 plus 1 is 2.5. No matter how many times you run this test, it is never going to go beyond this scope. 1.5, 1, and 2.5. That's it. That is what an example-based test is. Property-based test, on the other hand, doesn't start with an input. It starts with something else, because the input is something that I, the author, has to provide. Property-based test takes it a whole different direction. It says, okay, don't give me an input, give me a property of the system. Give me a fundamental aspect of the system that you want always to be true. And then the property-based test suite will generate inputs for me. And that's where it's different from example-based test, where I had to provide the inputs myself. And once it generates the input, if ever the test suite itself finds a property which is violated, then it tries to give me, the author of the program, the most minimal input for which the property doesn't hold. And that helps me fix the problem. So it starts with a property of a system. So what does a property look like? Let's say if you're building an application that has an API, for example, we can say that, okay, in my API, I never return stack traces, because that's never good, right? I mean, you wanted to do something and you get a null pointer exception. You don't want that in your API response. Or if you're building a banking application, for example, you want to ensure that the total money in the system remains constant even after bank account transfers. You don't want to invent money. Or if you're building a meetings application, you want to make sure that a person cannot be in 2 meetings at the same time, because that is just not possible. And for example, another one, if you're in a sorted array, if you're building a sorting algorithm, once sorted, every element in a sorted array is going to be less than or equal to the next element. So these are the properties of a system that would be taken as input for property-based test suite. So let's go back to addition. Let's try to define what properties of addition might look like. So it depends really on the application, but let's say for this talk, we say that one of the properties of addition is that 0 is the additive identity. So a plus 0 is always a, no matter what a is, or that adding the inverse to a number gives back the identity. So a plus negative of a is always 0. Addition is commutative, which means the order of operation doesn't matter. So a plus b is the same as b plus a. And addition is associative. So if you have 3 arguments, it doesn't matter which one you do first. So adding c to the result of a plus b is the same as adding a to the result of b plus c. So this is let's say, the properties that I want to define addition with. And here the interesting thing is that I'm talking about A as a concept. I'm not talking about A as like a number 1.5 or 5 or 6. A is any number, right? And that is what differentiates properties from examples, because examples are discrete points in a space, whereas properties are true for everything. This is where property-based test starts. So if I had to write a test for this, a property-based test, I would go exactly like I defined my properties. I would say, okay, assert that A is equal to the result of adding A to 0. So that is additive identity. Similarly, the inverse property would be something like if I pass A and my negative of A to the addition method, you get 0 back. Similarly for commutativity and for associativity, right? So these tests or assertions are not very different in terms of syntax or readability compared to the example-based test. The only difference is that these numbers, A and B actually, are not predefined. So in an example-based test, what we were doing before is that we said, take these examples, discrete examples, 1, 2, 5, 1.5, and then verify them. Whereas in property-based tests, we are not going to define those numbers. We are going to say that for any number A and for any number B, this should hold. And as such, there is this descriptor or an annotation in Java, which says that for all values of A and for all values of B, these properties should hold. Now, in this demo and this presentation, I'm using the jQuick library in Java, which is the go-to library for writing property-based tests. And this for all annotation is coming from the same library, which just says that for this test, the values of A and B will be generated by the test suite itself. And since this is a Java test after all, it has to be a method, and then we annotate it with a property, and that becomes a property-based test. And the moment I run this, it runs into a failure. And this is a simple method, right? I was very sure that the 4 examples that I wrote before were pretty solid, and I would have slept really soundly at night. But for some reason, something did not work as I expected. So first of all, after 285 tries, like 285 test cases, the system found something that did not work. Now, I don't know about you, but I would not write 285 test cases for addition, but the system can. And that's what we are going to use. So first of all, after 285 tries, it finds something that doesn't match our expectation. So that's number 1. So what is not working? So when A is 15.6 and B is minus 1.49, something is not working. Now, these are just numbers. These are not recurring decimals. These are not something out of the ordinary. There is no reason I would suspect that before writing the property-based test that there is something wrong with these 2 numbers. In isolation, these 2 numbers are just another number. To me, they hold no special value. So I would not particularly say that 15.6 is very special. But for some reason, the associativity property doesn't hold. And it says that, okay, I expected 15.11, but somehow it is 15.11000001. Now, clearly, there is some floating point arithmetic is going on here. That is clear from the example. But when I first saw this, even before I wrote the presentation, I was like, how is this possible? Like, this is just addition. This is just A plus B. How is this not, like, how is it not equal, right? So I went on to the JShell prompt, which is a REPL for Java, and I tried it out because I thought there was some ghost in the machine, right? This cannot be. This is the simplest thing I can think of, but it is still not matching my expectation. And indeed, if I try it out, it doesn't work. So 1 plus 15.6 plus minus 1.49 is not the same as 1 plus 15.6 and then adding 1 minus 1.49. And in fact, even 15.6 as a double is not the same as 15.6 as a float. And this fundamentally changes how I look at numbers. And the reason is, it is documented in Oracle's website as well, is that some numbers, like 15.6, are not accurate, cannot be represented accurately on binary. So they are recurring in binary. So therefore, they have to be rounded off because we don't have infinite memory. And depending on where the rounding off happens, the laws of associativity or some other expectation might be broken. So imagine if you were modeling a bank account or a currency addition with this floating point, there would be a lot of inconsistencies. And I had no reason to doubt that there would be something like this, not for something as simple as addition. But even there are surprises. And that's why finding bugs is much harder than verifying examples, because verifying examples are just the tip of the iceberg. Finding bugs, on the other hand, is a fundamentally much difficult problem. So the example-based test that we saw at the beginning, which I would be happy with if I did not know about property-based tests, was fundamentally different. How? The property-based test never said anything about individual numbers. They said, okay, whatever you define as binding properties of your application, just give it to me. The system will now search or find the problem space for any anomalies. Example-based tests, on the other hand, are sample test cases. So in the whole problem space, we picked and chose 4 examples, and we said, okay, if those 4 examples work, we are good. But it wasn't the case. So property-based test helps find bugs, whereas sample test cases or example-based test cases verify certain examples, which by definition doesn't do it for everything. And sample test cases give rise to what I call accidental quality. So initially, when we wrote the test, we wrote some four cases, and we were like more moderately sure that things are working. Like it's not negative, or it's not completely off, it's not infinity, it's not like 0 all the time, something like that. So basically, if it's a very simple application or very simple inputs, we would manually test it or write some examples, and it will be fine. But as the system grows a bit more complex or goes into the more complex inputs, we are bound to miss a few cases, because we are sampling test cases. We are not covering the whole problem as a whole. And what ends up happening is that we write some test cases, they pass, we are happy with it, but we miss something, because it doesn't matter how many we write by hand, we do have limited time, and we don't have infinite all the time in the world to just spend on one test. So we are going to miss a few. And that is where sampling of test cases gives rise to accidental quality, because if our test cases or our test suites don't catch a bug, what happens? It goes to production, and then users see it. And that is the definition of bad quality software. So when would we write a test case for something? We would write a test case for something, except for the very simple ones, only if we think that there is going to be a bug, right? We are going to have some intuition here that tells us, oh, that case looks suspicious, let me write a test case for it. And by definition of this nature of thinking, we leave out a whole space of unknown test cases, unknown failures, unknown bugs, things that won't occur to the person who wrote the test case. And that's why accidental quality is so prevalent. Why do we see so many software applications that go into production and see that, oh, this doesn't work. When I press this button, that doesn't work. It's not that the author wanted that button not to work. It's just that the author didn't think of that case. So that's what accidental quality is. So property-based test takes a different approach, where it says that, okay, same problem space, but instead of randomly picking and choosing, let's say, test cases, it does a systematic search of the problem space. And it's very similar to something like a depth first search on a graph. It's not exactly that, but it can be thought of like that. So it goes into more and more complex cases or more and more complex inputs until it finds one that doesn't match the expectation or the property. And that systematic search is not reliant on the author's intuition. It is by definition generated by the system, and therefore it doesn't have any of the biases that I as an author has. Like, I may not know about a particular case, but the system doesn't have that bias. And therefore this systemic search is a much better way of avoiding accidental quality. Now, it would have been fine if it just stopped there, property-based test, but property-based test takes it a step further. So it says that, okay, I will search the problem space for any kind of bug, but once I find an input for which the property doesn't work, it is going to also reduce the input to its most minimal form, so that it is easier for us to fix the bug. Because finding bugs is one thing, but ultimately we want to get rid of the bug. So helping the programmer or the author to get rid of the bug is much easier if the input is small, the most minimal noise-free input, right? So let's say we are implementing a sorting algorithm, and once we have the sorted integers, because this is a property-based test, the property is that in a sorted list of integers, every element is less than or equal to the next element. And because it's a property-based test, we say that for all lists of integers, this property should hold true. And we annotate it with the property as before. And when we run it, it might fail. But this time, the failure is in a 20 element array. I don't know where to begin because there are so many big numbers there. I don't know which one is the problem. And if we look at the source code of it, where do I start? Right? It's a 20 element array. Is the problem because it is 20 element? Is it because it is greater than 15 elements? Is it because there are big numbers there? It is much harder for me to now find where the problem is. So what probability based test does is that it says that, okay, I found this one problem, which is like happening for a 20 element array. Something is not matching your expectation. But let me try to dig a little deeper and give you a smaller input which you can deal with. And it says that, okay, after 12 steps of reducing the input, the original sample, I found an example which or a sample which is a 2-element array. Now, this is something I can work with because a 2-element array is fundamentally much easier to understand or try it out and figure out what really caused the problem. Similarly, if I run this test multiple times, it will run into a different kind of original sample because ultimately it is generating those numbers, but eventually it shrinks it down to a 2-element array. And that's really powerful because sometimes the original sample is going to be so big that it doesn't even fit on the screen, but it is going to try its best to shrink it down so that for me, the programmer, it is easier to find where the problem is. Because if I have a 2-element array here, I can look at the source code and it won't be a very hard job to figure out that the problem is in the second line where I deliberately put -2 instead of -1, and that's why the last element never gets sorted. So shrunk samples are very much easier to fix than the first sample that doesn't work. So this was an introduction to probability-based tests, but let's try to put it in a real application. So the code and the application that I'm showing you is going to be online. It's on github.com/mourjo/quick-meetings. I encourage you to try it out. But essentially, it is something that we have all had a chance to not be happy about. It is a calendar. Like there is hardly ever any time to meet all the people we want to. So this application tries to provide a solution for that. So it says that if I have an existing meeting on my calendar, I should not be able to attend, or I should not accept any meeting that overlaps with this existing meeting, which means that I can only, or someone can only invite me to a meeting which is outside of my existing meeting space. It's a very simple application which just says that prevent having overlapping meetings. And as such, there are only simple capabilities. It allows me to create meetings. It allows me to invite some other people to the meetings. It allows me to accept or reject invitations that I have gotten. And as such, there are, let's say, 5 API endpoints. So the point of this application is to simulate that the property-based test can actually be applied to real world. So this is a very simple application with 5 HTTP endpoints that allows me to create a user, create a meeting, create an invitation, and accept or reject invitations. So the creation of the meeting endpoint is an HTTP post meeting, which takes a bunch of parameters. So let's try that out. I'm creating Alice's first meeting in Calcutta. That's my hometown where I'm from. And the moment I do that, it runs into some kind of a failure. So let's wear the hat of the user here. Someone who just wants to use this application wouldn't be very happy if they saw this, because all they wanted to do was create a meeting, and they get in response something that says 500 status, internal server error, some null pointer exceptions, some servlet, some spring, some base, something that is absolutely not what the user wanted. In fact, if I was the user, I would lose faith in this product and not use this, because I tried something and it just kind of blew up in my face, right? But that is not just my application. In OSDI, a very prestigious conference in 2014, the authors of this paper presented that even in real-world applications, simple testing could have prevented many critical failures which actually went to production. So they studied systems like Cassandra, Hadoop, HBase, MapReduce, Redis. These are very standard applications that we use day to day in many systems, many large systems even. And they studied those systems and they found that 77% of production failures, which actually went to production, could have technically been prevented by unit tests. So we have the tools, right? We have the tools, but even though we are able to write tests and the tests are capable enough, failures go to production. So even applications out there have many fault lines. So the question in my mind is, why didn't the authors actually figure out where the problem is? I would say that the answer, in my mind at least, is that we don't have a way of knowing if you have enough tests, right? Because writing unit tests or example-based tests, we pick and choose examples, but we can never be sure that we have covered everything. The second finding from this paper was even more hard to think about in terms of example-based tests, because it says that some failures took more than one input event, which means that it took more than one user action to manifest. So let's say A happens, then B happens, then C happens, and then the bug happens. And because it requires so many prerequisite conditions, it becomes a combinatorial search problem, because there are so many possible actions that the user could have taken, and therefore it is not possible to handwrite all the examples down in an example-based test. So these are real examples from real systems that suffer, because not because tests are not capable, but because we don't have a way to ensure that we have enough tests that prevent bugs to go to production. So these are the gaps in example-based tests, because example-based tests focus on reproducing known bugs, because examples by definition is in the known space. The author has to know about it before they write an example for it. And past bugs influence current test cases. So if I know that I had a bug in the past, I will put it in my test case, and I'd be very happy that, okay, all the bugs are now covered. But what about unknown bugs? What about the bugs that I don't know of or I don't think about? And what about the bugs that require more than one combination, more than one user to take more than one action, and only then the bug happens? Because in production, it will, right? If you have more than 3 users, you can guarantee that the product will be used in more than 3 different ways. So if you just have one test for, let's say, 500 users, are we doing justice to the users? That's the question. Property-based tests in the real world can also be applied to overcome these problems of example-based tests. So similar to the addition example, we start with defining the fundamental guarantees that we want from a system. Then the system explores different kinds of inputs for which the system finds a violation. And once it finds the violation, it gives me the minimal input for which the violation was triggered. So in this application, the meetings application, we have 3 different layers. It's a very simple arrangement. We have the presentation layer, which is the API interaction. We have the business logic layer, which is implementing, let's say, the overlapping logic, and the database layer, which is interacting with the, let's say, the SQL or the relational database that we have. So in the presentation layer, we want to ensure that we never return 500 statuses, because 500 statuses should have been reserved for critical failures, like the database being down or the connection being dropped or something like that. It should not be something that we are reproducible in a test environment. Similarly, we want to always ensure that we return JSON responses. We don't want to sometimes return HTML, sometimes JSON, sometimes nothing. We don't want that. And the opposite of that, when valid data comes in, we want to verify that we get valid responses. So that's the presentation layer. In the database layer, we want to implement a SQL query, because in this application, we have a database, a Postgres database. So we want to make sure that the queries that are there works for all kinds of data sets that could be there in the database. So all types of overlaps and whatnot. And in the business logic layer, that is where we are going to simulate multiple users interacting with the system in multiple ways. And we say that no matter how many users we have, no matter how many ways they interact, we can still never have overlapping meetings. So that is what we are going to demo. Again, the demo is available on GitHub, github.com/mourjo/quick meetings. You can check it out, but let me go into the demo. So here I have the application. Let me just first run the application without running any tests to show you that it's not an application that is riddled with bugs, that doesn't work for anything. It works on the surface, but there are still bugs which doesn't meet the eye at first sight. So I have started the application. Let me go to the Swagger endpoint, which is just a UI to make requests. So let me try to create a new user. Let's say Alice. Alice is now okay. So I made the request. I got a 200 response. I get a JSON response. So seems like it's valid. Let me copy the user ID and minimize this one. Now let me create a meeting. So I try it out. I say Alice is creating a meeting. Say tech excellence. And from 14:30 to say 14:45, 15-minute meeting in Europe/Berlin, for example. And I say create the meeting. The request goes through. It gets 200, could have been 201, I guess. but we get a valid JSON response. So overall, there is like it's working at the surface. If these were tests I'd written, I would say that okay, there is no obvious bug. Like it's not always blowing up in my face, right? So let me stop the system and start to run the test in my in the presentation layer, because even though we know that we got JSON, we got 200, there could be something that is not tested well in that manually tested example. So before looking at the test, let me look at before looking at the output, let me look at the test. So first of all, it's a property-based test. This annotation says that, and because it's a property-based test, we have to the system will simulate the inputs. So we said that for all HTTP methods, for all HTTP paths, for all content type headers, for all accept headers, for all body, whatever combinations the system can generate between these, ensure that we always have a valid JSON, right? For whatever be the method, path, content type header, accept header, or body, ensure that it's always a valid JSON. Because we were getting it, right? When I manually tested it, it was always JSON. But is it happening for everything? That's the question. And once it is valid JSON, we also want to make sure that the response code is less than 500. Because 500 is reserved for unforeseen, unexpected, exceptional situations, but it should not be something that we are able to just simulate by passing a combination of methods, paths, or anything. And if I look at the test result, clearly, I get a failure. I see that there is an HTML response, even though I was quite sure that I was always getting JSON. So how is this happening? Let's first look at the original sample, because that's the first failure that the system got. And it says that the user being simulated, the user request being simulated here is a get endpoint for the /meeting/accept. Now, I wrote this application, so I know that this one doesn't exist, right? Get meeting accept doesn't exist, because in my list of endpoints, I see that only post endpoints are there. But that doesn't prevent the user from trying it out, right? It's an HTTP server, so the user can do whatever they want. In this case, the system was simulating a user request for get with meeting/accept. And there was something going wrong. And okay, this is a get with an HTTP body, which is frowned upon, but okay. And I see that there's a content type header, which is JSON, and an accept header, which is HTML. Okay, so that's one. If you look at the shrunk sample, we see that there is the method. This is the shrunk sample. After 10 steps, it realized that this is the smallest input it could get, and it's saying that get user. Again, this one doesn't exist. And again, it is saying that the user simulated by the application is saying that the accept header was text HTML. Now, this is a signal to me that there is something wrong with this part, because in Spring, the application framework that I'm using here is an opinionated framework, and it has some good defaults in place. So it says that if we, in the code or in the source code, do not implement an endpoint, then it will fall back to good defaults. And the good default in this case is that there is an error page that, because we don't have an endpoint defined, it will fall back to the error page in the format that the user requested. And the user requested in this simulation is text HTML. So the accept header is text HTML. Therefore, the system is generating an HTML response, right? So this is not something I would want, because it's an API. I always wanted to return JSON responses. But this, from the Spring's default set of configurations, is a good default to have, but it just doesn't work for me. So the fix is not that important, but the fix is to update the configuration to say that, okay, ignore the accept header if the user is passing something, and always use JSON, right? So even though the user, even though so far all the tests that I had ever written would be focused on the application endpoints that I really wrote, that the system was able to explore one case that was completely out of what I was expecting. Because if I ever write a test, I would not write for any other endpoint than these. But because property-based test explores this problem space, it says, hey, nothing prevents the user from trying a get user, for example. So let me try that. And it found something that I would not have written a test for. So when I run the test again, it still doesn't work, which is concerning. But let's see what is going on this time. So I see that there is an original error, and it says, okay, at least this time it's a JSON, right? So the configuration change that we made is actually working. But even if it is JSON, it's not quite ideal, because the status is 500 and the error is internal server error, it's again not something that I as a user would want to see. So let's see what might be causing this. So the original sample this time is post meeting. I know that this one exists. This time it simulated JSON for content type header, and accept header is JSON. The body also looks good. It's not empty or anything. So what is going on here? If you look at the shrunk sample, there is not much difference here. It's still post meeting. So I'm guessing that there is something happening in this endpoint itself. And accept header this time is HTML, but it's fine because we overwrote that configuration. Again, the body looks fine. It's a JSON. So what is going on? If I go a little bit up, I would see a null pointer exception somewhere. And it says that cannot invoke from because duration is null. What is happening here? Let's go into the controller. And if I go into the controller, I see that this is my post meeting endpoint. And I see that somewhere I'm doing request.duration.from. Right. So if I look at the expected input, the example says actually that there should be a duration and there should be a from and there should be a date and time inside it. So there must be something, the request that was simulated did not have this. So let's look at now the samples. The shrunk sample says that, okay, the body doesn't have duration, which is why it's crossing a null pointer, which is why something is going wrong in the system. But again, the user could legitimately forget to pass duration. But instead of telling the user that, hey, you know what, you missed a parameter, what we are doing is we are returning a null pointer exception. I mean, we are returning an internal server error because of the null pointer exception. And the reason is that the exception, the null pointer exception, is not properly handled. So if I make a typo in the request and I get an internal server error, what I would think as a user is that there is something wrong with the application because it says internal server error is something internal to the application. It would never tell me what my mistake is as a user. So here, what the fix again is not important, but the fix is to add exception handling, and not just exception handling for a null pointer, because this is a property-based test after all. It has to handle all the possible exceptions that could happen, like HTTP request not supported or runtime exception and things like that. Because for all of those cases, there is either a 404 or a 400 status code that could have triggered it. Because for example, if I remove just this one class, one of the simulated examples would say that, oh, if you do this, you would get a 500. And we never want to return a 500. So it encourages me to write better code by telling me, oh, did you think of that thing? Because it would break the expectation that you are saying that you should never return 500. So now it should pass. Now, basically, after 1,000 request response simulations, it is saying that for all the combinations of method input, method path, content type, accept header, body, there was no example that it could find that would cause a non-JSON response or a 500 response. So that's really something. I'm really feeling confident about this application now. But let me move on to the second demo, which is still in the presentation layer. But this time, instead of testing the unhappy paths, which is the error, the 400, the 500s, and the non-JSON responses, what we are going to simulate is that if we pass valid responses, valid input data, we expect 200 responses, 2xx. So here, what I'm saying is that this is a property-based test. It is that for all meeting arguments, and meeting arguments is something that I'm generating. I will show you that in a bit. But for all meeting arguments that are valid, and I know that this is valid because I'm generating it, create the meeting and expect a success. So what is happening here is that I'm taking the parameters. I'm saying that, okay, mock the service calls. I don't need the database for this one. I'm going to make a request, and I'm going to expect that I get a meeting created in response. But it clearly doesn't work. So what is happening here? It's saying that a meeting cannot start after its end time. It cannot start after its end time. But this is confusing to me because I specifically created I specifically generated inputs for which the start time would be before the end time. So let me look at the sample, the first sample that I get. I say that on 30th of March, I'm trying to create a meeting from 250 to 330, 250 to 305, which is after. So 250 is before 305 on the same day. But that seems okay to me because 250 is before 305. But somehow my error says that the meeting cannot start after its end time. But clearly 250 is after 250 is before 305. So what is going on here? Let's look at the shrunk example. It says that again something is going on the 30th of March 2025, 2:45 this time, from 2:45 to again 30th of March, 3 o'clock in Europe, Amsterdam. It is running into this error that meeting cannot start after its end time. The funny thing here is that the user specifically said create a meeting from 2:50, but the application for some reason thinks it's 3:50. Now what is happening here? How did 2:50 become 3:50? Although the ending time 3:05 did not become 4:05, for example, right? So there is something funny going on here, and the answer is well, in this on the 30th of March in Amsterdam, what happened? Well, actually, what happened was daylight savings was enabled. So on 30th of March, daylight savings was enabled. So 2 o'clock clocks move forward. So when the user from the request wanted to create a meeting from 2:50, it was actually seen by the system as 3:50. And this bug only happens when part of the meeting is in the daylight transition period or gap time, whereas the end of it is not. And the test was able to find it. And this is quite incredible. I would never have written a test for this because it is such a small set of possibilities that could cause this. The fix is not that important, but yeah, if you look at the fix, it is to say that I don't want to use the default constructor of date times in Java, which has this behavior that it will do the transition for us. In a meetings application, you really don't want that. So what we want to do is be more strict about it and do not allow these kind of transitions to happen. And in the response, we expect that a meeting could be created if it is valid for the user, but it could also be that the user is giving us valid input, but it just doesn't exist in the timeline. So therefore, it's actually an invalid input, even though it looks valid from the face of it. So if I now run, it should work. But let's look at how the data is getting generated, because that's interesting. Because we said that there are from generate all meeting arguments in a certain range. And in JQuick, if you want to have a custom generator, what you do is you write a method that provides this kind of data. So what we are saying is that take a start time provider, and start time provider for us is basically some arbitrary point in time and 6 months. So in a span of 6 months, take all the meeting durations of 15 minutes and 30 minutes and try to simulate that you can create a meeting and expect valid endpoints. So in a 6-month period, it was able to find, let's say, 1/2 an hour where daylight savings was getting enabled. And that's really powerful. After fixing that for 100,000 test cases, it is able to verify that no matter which time zone you are in, you're not going to run into this kind of issues. So now let me go into the third demo, which is in the database layer. So in this layer, we want to make sure that the queries that we are writing is valid. So ultimately, we want to avoid overlapping meetings. So if I'm in the source code for the test, what I'm doing is, again, it's a property-based test. This time I'm taking 2 meetings because we have to create a meeting and verify that the second meeting is overlapping or not. So I say that I take one meeting, take one meeting's duration, take another meeting, take another meeting's duration. Again, all of these are being generated by the system. And say that after you create the meeting, the first meeting, try to ask the database if the second meeting overlaps with the first. And manually verify by comparing timestamps. Because it's 2 meetings, it's easy to compare. Just compare all the start and end times. Verify that the database query that we are writing is working or not. And it clearly does not, because it finds a sample for which it doesn't work. So this time, let's look at the shrunk sample first, because it will just give us the really limiting case that causes it. So it says that from 10 o'clock past 1 second, if I create a meeting of 1 minute duration, and then create a meeting which is just starts before the first meeting, which is 1 second before, and lasts for 2 minutes, then it should have caused an overlap, but it didn't. So with this example, it is much easier for me to understand that in the case that the first meeting is being overlapped entirely by the second meeting, there is some kind of a bug. So it is actually that is actually the bug. I didn't write a query properly. So this red part of the query is actually buggy, which misses one case. And yeah, it's a bug on my part, and I've made bugs in the past. I'll continue to make bugs in the future. But if there is a tester like this which tests for my blind spot, that's really powerful, because even if I did not know the green part, I would still think that this has no bug. And the reason I say that is not because I'm denying that I have bugs, but because the intention behind the test, intention behind the query that was buggy, is to say that if I'm creating a meeting, check that the start of the meeting that is getting created is in between an existing meeting, or the end of the meeting is in between an existing meeting. So if the start or the end is in between an existing meeting, it is an overlapping meeting. But that is not true, because there is one case which is missed by my query, is that if a meeting starts before an existing meeting but ends after an existing meeting, it is still an overlap, but I miss that in my query clause. And that is something that is a flaw in my thinking, and that was caught by this test. I would not catch it. I would not write examples for it because I had a block in my mind, but my test did it. And that is the power of property-based test, because it doesn't rely on my intuition. If I have some logical flaws, if I have some cases I'm not thinking about, there is something that is thinking about it for me, and that's really powerful. So once I fix the query, it should pass. Let me show you the test while it runs. So here, what I'm doing is I'm saying that if the database overlaps, then ensure that the result from the database is the same as the result from my manual comparison. And the whole intention of this is that when we go to production, the database will have a lot of combinations of inputs, right? So a lot of combinations of start and end times that will be there in production, but it may not be something that I've thought of. And the whole point of this property-based test is to simulate all those possible combinations of start, end, and a new meeting. And with the fixed clause, I think, yeah, it is passing after 1,000 combinations of two meetings, one existing in the database, one being created. It doesn't find any overlap. So that's helpful, because I could still write a bug. If I had to re-implement this application from scratch, I'm pretty sure that I will still make the same bug, because it's internal to me, the way I think about it, right? Let me go into the more fun stuff now. So we did the presentation test. We did ensure that every time there's a JSON response. We tested the query. Now let's simulate user actions. And this is the business layer that we are testing. So here we have a slightly different way of writing the test. Again, it's a property-based test, not very different that way. But we are saying that this time, for all meeting actions, so we are going to simulate what a meeting action is. Meeting action, again, provided by my custom provider. It says that start with a clean slate, and simulate user actions, like creating a meeting, inviting another person to a meeting, accepting a meeting invite, and rejecting a meeting invite. So these are the possible actions that my system's users can take. What this will provide to the test is that it will interleave these actions in many different ways. So it can create a meeting, it can invite someone, and for all these combinations, ensure that no action or no combination of user action ever causes an overlapping meeting. And clearly it doesn't work. So if I look at the sample test cases, what it is saying is, and let me just remove this. What it is saying is that this is the shrunk example, right? It says that the action is create, being taken by the user Bob. So Bob is trying to create a meeting of some duration, and then Alice is trying to get Alice is being invited to Bob's meeting, that is meeting index 0, that is Bob's meeting. So far so good, nothing bad here. Alice is now creating another meeting which is overlapping with Bob's meeting. So far so good, because Bob created a meeting, Bob invited Alice to the meeting, Alice created her own meeting, but then Alice accepts Bob's meeting. So here Alice was invited to a meeting, Alice accepts that meeting, but in the middle Alice created a meeting which overlaps with Bob's meeting. And this is a kind of interleaving action between two users that cause the overlapping meeting to still happen, even though we ensure that the query doesn't have a bug. So there are two users doing multiple actions, and then there is still a bug. And this is something that I can explain to you in a what, like 30 seconds, because the system went through a much larger problem space and it found the original failure that is a much deeper sequence of failure. So it involves so many steps that I probably, if this was the only failure, I would probably give up before trying to explain to you what is going on. Interesting thing is that a shrunk sample reduces the noise. Here you see just Bob and Alice is here, but in the original sample, there is this Charlie user. And Charlie is a third user, which is not required for this failure. So it rejected that third user. So 2 users is required for this test, for this case to fail. Similarly, the action reject is not something that is part of this input, and it is again something that that was removed from the shrunk sample, so that I, the developer or the owner or the author of the test, could figure out what is going on and explain to you in a call that, hey, you know what, this is going to break expectations. And the fix is not that important, but the fix was in the accept action. We should also check whether that action is going to cause an overlapping meeting or not. So multi-user actions interleaving with each other, writing examples by hand is not something that would be very simple to do. But now that we have a way to model user actions, right? We have a way to model a creation of a meeting, inviting, accepting, rejecting. We said initially that we don't want overlapping meetings, but we can extend this further. Now that we have such a robust method of doing different kinds of combinations that the users would do in production anyway, we can extend this to say, okay, we don't want overlapping meetings for sure, but we probably also don't want, we can add to the guarantees that the system has or extend the properties that we initially started with. And that would be possible because now we have a framework that does this for us. So now the test, I think, is passing for 1,000 combinations of user actions. The overlapping test is working. So there is no overlapping meeting for any kinds of user actions up to 1,000 levels of depth. But let me just add now, let me increase the system's guarantees or the properties that we want to simulate. And I said that, okay, now we have a very robust way of modeling user behavior. So let me just say that, okay, now we said we won't have overlapping meetings, but we also probably don't want meetings to be empty. So instead of just checking for overlapping meetings, which we were doing before, let's add a new property of the system, which says that, hey, I don't want any meeting to be empty. And this can be a very simple SQL query that gets checked to say that every meeting must have at least one owner or one accepted invitee. And that doesn't work either. And this time also, it gives me a very simple shrunk sample that says, okay, user Alice creates a meeting, user Alice rejects her own meeting, and then you will have an empty meeting. Again, the first sample is much more noisy. It has more users. It would be a much harder time to figure out what actually went wrong here. So that's property-based testing for you in a real-world application. So coming back to the demo, the slides, the demo, as I showed it to you step by step, is available on my GitHub repository, quick meetings, github.com/mourjo/quick meetings. You can try it out, suggest improvements if you have any. And so what did we learn? We found bugs, right? What did we find? We found that sometimes there are 500 statuses, sometimes there are non-JSON responses, sometimes there are daylight savings validations bugs because time is weird. Sometimes there are SQL queries that are being missed, are not covering every case. Sometimes accepting a meeting causes an overlap, but only sometimes, only if some other users did something. Sometimes rejecting a meeting creates empty meetings. Now, none of these test cases were hard-coded in the test. There are no examples for these. There are no test cases that identify just these. There are generic properties that allowed us to find these holes. For example, I would never write a test case for daylight savings. I still don't understand daylight savings after 2 years in Europe. I wouldn't definitely have written a SQL query that didn't have the bias that I had originally. And these cases are not something that I can rely on myself. That's why I would think that my example-based tests are fine and go to production, because I just wouldn't think about it. But a system like this would. So that's the difference between reproducibility and discoverability. Example-based test cases focus on reproducing existing bugs or known bugs. It verifies particular scenarios or past bugs, but Property-based test focuses on discoverability. It searches the problem space, which is fundamentally different from examples because it doesn't rely on the author's knowledge. And this requires a shift in the mental model because it asks us to think of first principles. What are the guarantees that we want to provide from our systems instead of spending hours just to enumerate hand-pick examples? It is a much bigger and better guarantee to know that our system has some fundamental expectations that a user come to us for. And if there is ever a bug, the property-based test system finds the most actionable feedback to me, the author, so that I can fix the bugs. A shrunk sample, which is easier to work with, which is easier to present in a talk like this. So when a build passes, whether it is a property-based test or an example-based test, what it really signifies is that in this particular build, there was no detection of a bug. The absence of evidence here is not the same thing as the evidence of absence. A passing build that does not imply that there are no bugs. It just implies that in this particular test run, there was no bug that was detected. So the more exhaustive our test cases, the lower is the chance of having bugs in production that our users use. And uniformly searching the problem space, as property-based tests do, makes it much easier or more robust than handpicking examples that traditional tests suffer from. So the question is, who ultimately pays the cost of accidental quality? Because whether it is something as simple as addition that doesn't work as you expected, or null pointer exceptions that you surface to the user, or a query that you just didn't think of all the way through, because it happens to me at least, or something more complex where you have multiple actions, multiple users doing multiple things, which only manifests the bug in a particular set of scenarios and has a lot of noise that is just not possible to handwrite by manually enumerating it. Ultimately, it is the user that pays the cost of it, because the test suite is the last line of defense. Automated test suites are the last line of defense, because if that doesn't catch a bug, it goes to the user. And if the user sees that our systems are full of bugs, they will just go away to the competitor, to something else, or not use it. So handpicked test cases being the last line of defense is not very ideal, because it leaves out a lot of open-ended questions, and that is the cost of accidental quality. A systematic search like property-based tests does a better job of guaranteeing that last line of defense is more reliable, more robust. It is not 100% accurate because it is still doing a search, but it is better than handpicked test cases. And that's why I think avoiding accidental quality with property-based testing is something worth talking about and trying it out. Thank you. I think that's my talk. I can take any questions.
Awesome. Thank you very much. And great job for this. I remember back then when I was exploring this topic, like 5 years ago, I was searching for videos and all this, a lot of learning material in this topic, and I couldn't find so much, or the ones I found were very basic examples like additions. But here we had a lot of business domain specific examples, so excellent job. So in the future, if someone wants to learn about this, I will recommend this talk. Nice one. I like it. I also like that you really emphasize this difference and this mental shift we need to have when we test our software, right? I mean, because, when we write example-based test, we verify, we reproduce a bug, but here we search for the bug, right? And that's what developers miss, right? That when they write test, okay, let's write a test for the happy parts and we are done. But no, you should have the mindset of breaking the software, right? We should be really searching for bugs and searching for defects in our existing system. So yeah, excellent job. I liked. Yeah, we have plenty of questions, so I would propose to go through them one by one, and you can answer. So first of all, from Tim. It was in the very beginning when you mentioned writing tests. So with writing tests, are we assuming micro tests, TDD, or test after, or system, or contract, or end-to-end tests? So basically the question is, what kind of tests you use for property-based testing? I think that's the best way to put it.
Yeah, that's a good question. I think property-based test by definition has to be a little bit after you have developed the system, because while you're writing the test in TDD, at least, it helps you to write the code. But property-based test is useful once you have developed something that can exhibit those properties. So if you have, so the way I would think about it is that microtest or TDD should exist, which help you write at least feature completion, that you want the endpoint to exist, for example, or the endpoint to return something. But once you have developed a basic set of features and you go slightly above and you think about the product as a whole and the guarantees that the product provides, and you have something of a product to exhibit, that's when property-based tests come in. So no, I don't think it replaces TDD. It is not even test after, I would say. It is somewhere in the behavior testing domain kind of thing, where you have a product that does some things and you can ask it questions like, hey, I know you're going to do this. Are you really doing this? That's kind of, it's not while writing the source code.
Mm-hmm.
Does that answer the question, or do you want me to go deeper?
I think yes, but additional, maybe you could explain that. So what kind of tests they are? I mean, execution timing wise, what would you because end-to-end test, for example, is very slow, right? And if you generate a big number of inputs, then such tests would take a lot of time. So whether it makes sense or not, what is your experience on this? So what kind of test, I mean, in terms of execution time, would you use for property-based testing?
Yeah, so it depends on how you're writing the property-based test, right? So property-based test could be end-to-end, or it could be unit tests, or it could be something much simpler as well. Yes, there is a penalty to pay because it is generating a lot of input. So simple example-based test is going to take much shorter time. Whether it is end-to-end or integration doesn't matter, because we are generating a lot of more test cases. Fundamentally, it takes more time. However, if we want to test a certain kind of product guarantee, let's say we don't run it every time or every build or every merge request, we can run it at the end of the day or something like that to test the product as a whole. Now, you could do it at the level of end-to-end testing, or you can do it even at the presentation layer, as I was showing you, where I had mocked all of the databases and everything. I was just testing the validations or the responses being JSON or the status of the HTTP endpoints. You still have those tools to make it faster, but it will never be as fast as like writing 4 test cases, because here fundamentally you're running 1,000 test cases. So it is going to take some time. It is going to run more CPU cycles, but it doesn't mean that you have to run it every time. You can even like batch it up and run it hourly or daily or something like that, if that is a concern.
Very good one. That's a great answer. Thanks a lot. Let's jump to the next one because we have many. Valentina says, or asks, to what extent do you rely on property-based testing versus other test types, like unit tests?
Yeah, so I put property-based testing at the same level of software development cycles, where I have, let's say I've implemented some of the features and I want to ensure that those features are working as expected. So let's say I'm building a new kind of meeting in my meetings application, and it came as a user requirement. I said, okay, I will implement a new endpoint and then write the query and then end-to-end test it. Once the feature is ready, that's when I would say, okay, is this feature actually doing what the user requirement was? And that's where I would write property-based tests. So once I've written like the basic functionality and it works manually, let's say, that's when I would put property-based tests to ensure that I have not missed anything. And then once it is working, I know that even if I change something later or something in some other user requirement comes and this changes the expectation of my current product, it would also catch that. So the way I would think about it is build the feature, write a property-based test, and then ensure that all the expectations from the user requirement are met.
Yeah, very good point. Yeah, it's an additional layer of confidence. Yeah. And what based on experience, what I found out also that, let's say you write a property-based test and it passes, but in one day or in 1 week it starts failing because it works with the combinatorial and it's a big number of inputs, but it's not the whole set of inputs. It is just using it's just a big number of inputs which is randomly generated, and maybe it passes today, but tomorrow it starts failing. So later on you discover some bugs. So yeah, it's very powerful.
Yeah, that's actually a good point, which I did not touch on in this presentation, is that because of the randomness, it is possible that let's say you're testing 1,000 times and there's a very obscure bug that only triggers once in a fortnight, then the build would feel flaky, but it's not flaky. it means that there is something that is not working. It's just that it is rare. So in jquick, the library that I was using, there is a random seed file that is generated, and you can take that seed file from the CI build or whatever and repeat that case multiple times and start the build from that point, so that you don't run into this, like, you fail once and then pass, then fail once and then pass. So you can always get the state at which it was failing. There is a file that gets generated at the end of the property-based test. You can take it to your local machine and try to figure out what exactly happened in that one build. So it's not always going to be random.
Yeah, very good one. All right, so let's see the next one. Yeah, in the beginning you were talking about unknown bugs, and there's a question: are the unknown bugs interrelated? So are they connected or not? What's your experience?
The fact that it is unknown means that I don't know if it is related or not, right? That's the beauty of not knowing something. Unknown unknowns. I think Donald Rumsfeld, who was a defense secretary in the US, came up with this concept of unknown unknowns. The things that I don't know, I won't be able to say anything about it. And that's why a last line of defense is unknown unknowns, whether they're related or not. It doesn't really matter. It's something that is a mental block for me. I would never know anything about it. And something that tests that for us, or that space for me, is already a huge relief for me, because if I don't know something, I can't expect to write a test for it.
Definitely. Yeah, great answer. So let's jump to the next one. Let's discuss this. So, hello from India. Meetings are always complex. Property-based testing can be such a savior. And my question is, so do you use property-based testing for only complex problems, or you found it useful also for simple ones, or what is your take on this? So can it be used in every kind of simple and complex problems, or medium, or what is your take on this?
Yeah, so that's kind of the point of this whole presentation. Started off like half a year ago, where I was building a lot of APIs, right? And fundamentally, it doesn't matter what the API is doing. At least for the presentation layer, there are some tests which can be common, right? Like at least making sure that we always return data in a certain format, or making sure that we never return 500s, which I've seen more than I would like, right? Every little thing goes wrong and it's internal server error. What does that even mean? These are good defaults to have, but they are just not good experiences for the user. So if I say that I write property-based tests for everything, I would be lying. But I do have a set of property-based tests for Spring framework that I just reuse everywhere, right? For the last 6 months, every API that I've written, at least personally, I've just copy-pasted those from the presentation. For the more complex ones, like the user interaction, of course, that depends on how let's say how correct I want my system to be. Sometimes it is possible to spend a lot of time and write these tests. Sometimes it is not, but it really depends on how much of a risk we have an appetite for. Like if it is a very sensitive application, or if it is a new feature that we are providing to a new segment of users and it blows up every now and then, that's not a good expectation. So we want to write a test for this. Or it is something that is internal, that is not going to be used by a lot of users. It is just going to be used by my team only. I would probably not spend that much time writing very specific property-based tests for it. So the cost aspect is there, especially when developing it, but at least some of it can be made common in libraries. Like for Spring, we could have just a few basic starting points.
Very good one. Very great answer. Thank you. Next is, are there alternative libraries to this jquick available for property-based testing? So it is for Java, right? So
yeah.
Do you have any other recommendation, or this is the best tool in this domain?
Yeah, I think there is this hypothesis library, which is very common, very famous in Python. I think there is a Java library as well, but I think hypothesis is the first hypothesis in Python, and test.check, I think, in Clojure, and quick check, which is the original paper, and the quick check implementation was in Haskell or Erlang. I think it was in Erlang. Yeah, so those are in other languages. In Java, I think there are a few others, but in my trial and error, I found this one to be very thorough. I can't recall the other Java libraries, but for Python is hypothesis. For Erlang, it is quick check, and for Clojure, it is test.check.
Mm-hmm. And for Rust, it is prop test. So
I see. Yeah.
That's a really good one. That's really powerful. So that's what I use lately, and it has a lot of support for every kind of things. Much more support than the one I think in C# and F# you have FS check, if I'm not mistaken, and that has much less support compared, for example, this Rust one. Yeah, it depends. Yeah, but yeah, very good ones. Thank you. Check it out. I recommend everyone, if you never used property-based testing, check one of these libraries out, and try it out, because you will be surprised how many bugs you have in your software. So let's see the next one. So she says, so it's a conclusion from her, Urmila, which means property-based systems are superior to example-based tests. I think she meant property-based tests. So do you think that property-based test superior to example-based test or not? What is your, we know already the difference because you explained, but what is your take on this?
Yeah, that's a tricky one. I like saying anything is superior to anything in software engineering is a dangerous door I don't want to open. But you can't have a system just with property-based tests. Let's just say that it is far too costly to just have property-based tests in a project which doesn't even have tests. So I would not go with saying that property-based test is superior in that sense. But definitely, the underlying point that I'm trying to make is that example-based tests are not enough. They are a good starting point, and I think they do have a lot of value in being there in our tool set. But if you want something more, we should go a little bit beyond, and property-based test adds a lot more value on top of it. But it's not really superior in that sense. But yeah, it has its own advantages.
Mm-hmm. Yeah, exactly. It has a different goal, namely to searching for the bugs based on a big number of input.
Right. Yeah. And then there is the cost aspect as well, right? I mean, both writing property-based tests and running them, you pay a lot more in terms of running it, writing it, thinking about it. And rather than just writing, like for the addition example that I started with, I would probably not write a property-based test for it. I just wrote it for this example. I would not even write a test for it if I'm being very honest. But if I did write a test for it, it would be an example-based test.
Exactly. And also sometimes with property-based testing, is difficult, or there are domains where it's difficult to figure out or find properties, because that's what you need to do in property-based testing. You need to find an invariant, you need to find a property which should hold after the test run, after each test run, and you need to find that. So it is not like, hey, it's difficult in some domains. Like they want to, for example, if you want to assert what is the name of the user when you store it in a database, then there is, of course, you can find the properties that it's bigger than 0, the length is bigger than 0, etc. But if you want to specify, hey, the exact exact name is stored for the user in the database, then the example-based test is the best in that case. But it's they have different goals, but both of them should be in our toolkit.
Right.
Yeah. So let's go. We still have very good ones. I like it. The audience is very active today. So from Tim again, he says, since this is randomized, it is not really appropriate for a pre-commit hook or for a CI action. Where do you fit the property-based testing in your development process?
I wouldn't put it in a pre-commit hook, but I have put it in CI actions actually. Because even though it is random, it is not like absolutely random. So it starts with a small sample. So for integers, I think it starts with 0 and it grows to find up to a reasonable length. And then if it finds a property that doesn't work, it shrinks it down. So I don't see why I couldn't put it in CI. It is not absolutely random. Like it's not a math.rand, something like that. It is actually growing in a certain sequence. If a property-based test runs in a CI, the only thing that you pay for is the cost of running that machine. But there is, you can reduce the number of tests you run. So you can always say that I don't want like 100,000 test cases. A good enough estimate is, let's say 100. It depends on the test actually. So it is, because a property-based test could have been, let's say, a mocked test at the presentation layer. I don't see any harm in putting it in a CI pipeline. In fact, I've put it in CI pipelines for some projects also. Especially, I remember a project where I was working with a lot of input parameters, and just writing the number of combinations by hand was not enough. Like, I would always miss something. So in that case, also, putting it in the CI is, I don't see why it would be wrong, because especially think of the case that you just write a property-based test once, but you change the feature multiple times, your properties are still not going to change, right? Let's say we allow meetings to now have, let's say, a room associated with it, right? It wouldn't change much of the existing meetings than to have another additional, let's say, person who is a room. So the guarantees of the system doesn't fundamentally change as the product grows, but it's important to make sure that the original expectations don't break when you make new products, right? So that way it's okay to put it in CI, I would say.
I agree with you, and that's what we also do. And given you have to really think about the configure the number of tests, and you're right, it shouldn't be 100,000, because that would lead to, it takes a lot of time, multiple seconds or 1 minute to run that one test, which can be fine, but if you have 10 of them or 20 of them, then CI can become really long, half an hour, even more, which is unacceptable in some domains, especially in the extreme programming and continuous integration, where you want to, you continue trunk-based development, you want to have a CI which is less than 10 minutes or even less, because you want to get feedback of the system quickly. But I found the sweet spot having 100 as a number of tests for a property-based testing, personally, in my projects. Because let's say if we have a unit test which takes 10 milliseconds, then if you run it 100 times, then it's not concurrently, that's 1 second. And it's more than a few milliseconds or 10 milliseconds, but the confidence you gain is worth it, I would say. So it is a sort of trade-off that, okay, our test suite will become, it will take longer, but you get a good confidence that your code really works, and this is the price you need to pay, unfortunately, in many domains. And of course, we don't need to, as we discussed, we don't need to force this property-based testing, because only in places where really proper or appropriate properties can be, set up or determined. But it's still, they take time, absolutely.
Yeah.
And also, once I had a question, I remember, because I was presenting similar topic and I was asked why, and I wonder what's your answer, but it's not a difficult question. So why don't you generate why don't you generate tests for all kind of inputs? Why do you need this randomized thing?
Generating all kinds of data is not like it's infinite, right? There is no all kinds of data for, if you take the most simple, just integers and infinite set. So how many would you write?
Exactly.
That's one. And the second is that it's not always just the combinations being a static list, because you have to factor in that software changes, products change, requirements change. So if today, instead of taking just 2 parameters, you add a third parameter, the generation now changes depending on your product, right? So I think it's theoretically possible to write it down in a piece of paper and like have the system generate it and repeat it. But what is the benefit that you get out of it instead of randomly generating it on the fly? Because if you randomly generate it on the fly, then the process of shrinking is also possible. That you generate it like A, B, C, and then you say the C fails, then you say, okay, D prime or B prime, and then A prime. Okay, this is the smallest one that is failing, kind of like a git bisect kind of thing. So because you generated it through a sequence, you can now trace back to a slightly smaller sample that still has the same kind of failure. So that is one advantage of generating rather than statically using all kinds of really random data. It's not really random, it is random walking. So it is random based on certain logic, which grows and
Very
shrinks.
good. Very good one. Very good answer. Thank you. Yeah, exactly. So basically, this shrinking and finding the best case for you to reproduce the bug so you can fix it. Basically, that's one of the main benefits of it. Of course, it takes a lot of time. And the more parameters you have in the game, then it just increases exponentially, I guess, or even more than the number of inputs. Yeah, excellent. Thank you. The next one from Sergio. Are you familiar with the Berry-O'Reilly residuality theory? If so, how is it similar, different to PBT, and could be both be combined to come up with something even better? So first of all, are you familiar with this or not?
No.
Okay.
No.
Me neither.
Unfortunately.
Me neither. So unfortunately, we cannot answer this, but there is room for improvement for both of us then.
Yeah, for sure. Always.
Yeah. So okay, the next is. Yeah, this is a good remark from Tim. I had a similar thought. So you say avoiding accidental quality, and that's confusing phrase because we never avoid quality. That is godness, not error. So, yeah, what is your take? Because I had similar thing because before this talk, I had the presentation material and I looked at the title and I was also questioning, okay, why do we want to avoid quality? So can you please again explain why did you use this wording in this context?
Yeah, that's actually a good one. I didn't think of it that way, to be honest. But yeah, avoiding accidental quality, I really meant to say avoiding accidentally good quality. Because when you say a product is of superior quality or this is quality, and that is, there is an, like, at least in my mind, there is an implicit goodness with it. Like something is of a higher quality or better quality. But yeah, I probably missed saying that avoiding accidentally good quality. But if I go back to that phrase, it comes from this paper called No Silver Bullet, I think, where the author talks about accidental complexity and essential complexity. And I try to draw parallel from the complexity world into the world of quality. And that's where the term accidental quality came into my mind, because quality is something that you can guarantee that I give you quality software. You can say that if you come to me, you will have quality over quantity, that kind of thing. So when I said quality, I meant like good quality. But yeah, fair enough. It's goodness and not bad quality.
I see. Okay, cool. Very good one. How about AI? I mean, AI. It's a very hype topic. It's also very useful. Of course, it has its defects as well. Anyway, so do you use AI can also generate a lot of kind of tests. It can generate a big number of inputs. So do you use AI for property-based testing? What is your experience? Whether AI is well trained or not? So what is your experience with AI using in this domain? So in the domain of property-based testing, I'm interested in this.
Yeah, I haven't used AI just in the specific domain of property-based test, but I have used AI to generate test cases. And by generating test cases, I mean examples for my code. So it is kind of orthogonal that way. When an AI writes the test for me, it is doing it, and I think there is a lot of value in that, and I think it is somewhat of a competitor in that sense to a property-based test, because property-based test has an algorithmic way of generating inputs and growing and shrinking them. Whereas AI is more like it looks at the code and thinks for itself how much it can and writes the test examples for me. That is my exposure with writing tests with AI. It does a very good job in that sense. But I still feel that property-based test has a better exploration feature, especially for the more complicated cases. Because even if the AI is writing it or not, it is me who is asking questions about the product itself. Like, what do I really want to provide as a guarantee to my users? And once I have done that, whether it is AI or property-based test, if the mechanism doesn't really matter, what matters is the starting point, thinking of the product as a holistic, guarantee that we provide to the people who are using it. So yes, I think AI can bridge the gap, especially because property-based test has a learning curve, because it has a lot of things that you have to like figure out before you can actually implement it. AI is faster at getting us to a better coverage, but I still would feel a little bit more comfortable with property-based test because of its algorithmic exposure. Like it really explores the problem space in a more maybe I'm just a little old-fashioned, but in a way that I understand better.
Exactly. And also the AI generated code, right? So AI generates a lot of code. You want to verify it. Yeah. And of course, you can verify it with tests, and you can ask AI to write a test, but still, it doesn't give the full confidence. So, personally, what I use is surely mutation tests to figure out whether my tests are good enough and whether I test really everything, not just execute the given code, but I also challenge the given given things, properties and fields. under the test, and also property-based testing to really explore and find bugs in sort of rare situations or in a given, in a combination of inputs.
Yeah, and I think AI also has bias. The whole point of property-based testing is to take away the bias, at least my bias. If I replace it with the AI's bias, it's another bias replaced for my bias. Like the fourth example in the clause of the queries, replacing one bias with another bias is not necessarily better. A purely simulated test environment is probably something that is easier to trust.
Mm-hmm. Very good one. All right, and how about concurrency? Can you test the concurrent state with this property-based testing? What is your experience? What are your recommendations or tips in this regard?
Yeah, it's a difficult one because concurrency means that things are running in at the same time, but property-based test kind of grows the input one after another. So I think it's possible to generate the simulation context or number of threads you want to spawn, something like a control sequence. But if you just want to test concurrency, there are, I think, better tools meant just for that. Like I think Jepson is one. I think TLA Plus would also allow you to do it, but that is kind of outside the scope of property-based testing because you are really asking the questions about the product. For a very specific domain like concurrency or database concurrency models, for example, there are much more superior tools than this. So I would look slightly elsewhere for concurrency testing.
Mm-hmm. Very good one. Here we get a remark from Valentina, which is spot on. So she says we could also say that the cost of property-based test is the speed of feedback.
Yeah, that's a good one actually.
And here she says that's why we should be first relying on XML-based tests to get fast feedback.
Yeah, that is true, but I will just add one thing to that is that initial few cases is the example based tests give you quick feedback, but once it gets a bit more complex, the fact that you can't write examples for everything means that you can't get feedback for those missing things either. So that's where property based test also gives you a longer feedback, but probably a little bit more valuable, especially when there are more things. So feedback is coming from you from another system, not just yourself.
Exactly.
So that's also something to worry about.
Mm-hmm. Yeah, and finally, she also added that, and then if XML-based test passed, then running property-based test for comprehensiveness. Exactly, this is the
for sure.
Yeah, exactly. Very good one. And another last point to close is that coupling test to the code structure and behavior. We have this that we shouldn't couple test to code structure to private methods or these internal things, because otherwise our test will be too fragile. But I found that for property-based tests, time to time I make exceptions, and again. To gain more confidence, because again here we talk about we are randomize the number of inputs, and the lower level I am, the more I can randomize those inputs, the lower level things. So it is also a sort of cost of I couple test the code structure, which can break a property test, but I don't have many, but I get a good confidence, and those places I can figure out some bugs. What is your experience on this? Just briefly in half minute. That do you also
it does make sense. It absolutely does make sense what you're saying. But if you focus on the properties itself, how you're simulating that is not that important. So it's okay to make a few corner cuts because it is costly in the first place. So the closer you are to the more mutable or modifiable part of the system, the better it is to get the feedback. Otherwise, you are just testing, spending a lot of CPU cycles just doing the end-to-end coverage.
Exactly. That was a good word. That the closer we are to the mutating, the most mutable place of your system, the best property-based test you can write. Amazing. I love this as ending. Well, Mourjo, thanks a lot. Thank you very much for this amazing talk. I think we all enjoyed and learned a lot. And let's see what is the topic of next is exactly next meetup, 12 November. by Tim Ottinger, who was also asking some really good questions today, and he will talk about TDD and LLMs. Very exciting topic, so we're looking forward. Stay tuned. So again, Mourjo, thanks a lot for coming and having this great talk, and also thanks for the audience and everyone who participated. And of course, you can find us, join us on Meetup, follow us on social media, and again, huge thanks to our sponsors, Optival, Mocha, and Cordify, and to our partner, QUnit. So again, thanks everyone, and see you next time. And Mourjo, again, thanks a lot, and wish you a great day further. Goodbye.